Iceland's volcanic eruption in it now hour 45 of Iceland's latest volcanic eruption, and to the surprise of many its lava effusion rate has remained fairly constant, albeit decreasing slightly during the last 24 hours. Currently, only a singular 280-meter-long stretch of the original 3,500-meter-long fissure is still erupting lava, which I estimate to be occurring at a rate of 15 cubic meters per second. While the existing fresh lava field has expanded during the last 24 hours, the rate of flow advance is quite negligible, being less than 1 meter an hour. However, all fresh lava is now flowing towards the south, so the potential does exist for additional lava lobe expansion in that sector. Yesterday, I estimated that up to 30 million cubic meters of lava had already erupted and 120 million cubic meters. This confused a number of people. After all, the shallow magma chamber which fed this eruption only contained 11 million cubic meters of molten rock before it erupted. So, where did the remaining 19 million cubic meters come from? The answer is the original 15-kilometer-long dike which was emplaced during a failed intrusion which got close to the surface but did not erupt on November 10 of last year. That emplaced 120 million cubic meters of magma, and this magma will take years if not decades, perhaps even longer to cool. The thicker a lava flow or underlying body of magma is, the longer it will take to fully cool. For example, while a basaltic lava flow with a thickness of about 5 meters will take 5 months to cool, a lava flow of the same composition which is 30 meters thick will take 3 to 5 years to cool. And, underground this figure greatly increases due to the overall higher temperature. My point is that the November 10 magma is still quite hot, probably around the same temperature it was when first emplaced. This material is likely being utilized as an extra reservoir of sorts which is supplying the ongoing eruption in part. Also, for 30 million cubic meters to have erupted, the average lava flow thickness would only need to be 4.65 meters or 15.26 feet. Several reporters who got somewhat close to the eruption site yesterday noted what could be correctly described as very small amounts of tephra. Scoria specifically involving porous but still fairly dense rocks filled with holes known as scoria and fine strands of golden volcanic glass known as Pélé's hair. Scoria forms when gas-rich lava is quickly expelled from a volcanic vent, with numerous gas bubbles inside it greatly expanding to form a porous mass. Any scoria produced in Reykjanes's ongoing eruption was likely produced during the first 8 hours of the eruption. Pélé's hair, on the other hand, Pélé's hair forms when a thin film of lava is ejected upwards as a result of a volcanic bubble bursting during lava fountaining. This stretches small amounts of molten rock originating from the edge of the bubble into incredibly thin and elongated strands of material, and since it cools almost instantaneously, it becomes a type of volcanic glass. Despite the existence of this tephra, the volcanic explosivity index of the ongoing eruption is still a 0, as up to 10,000 cubic meters of tephra can be emitted to still remain in this designation, and I estimate that less than 10 cubic meters of tephra has been emitted. It is unclear how much longer the ongoing eruption will last for, but I am almost certain that we are at least 2/3 through the eruptive sequence due to there only being one fissure left. Eruption length seems to be directly proportional to the peak lava effusion rate during the first hour of Reykjanes's eruptions. Here is the current hazard map for the overall volcano and the town of Grindavik. As a final note, I would like to thank my new patron Roland Warmerdam for supporting this